Hello everybody, today we're going to be working on introducing exponential relationships. So we spent most of first semester working with linear relationships, which are relationships which graph a line. Today is the first day we will introduce a nonlinear relationship. There are many types of nonlinear relationships, but the one we'll focus on in this unit is called an exponential relationship. Let's explore the difference between linear and exponential relationships. If we have an increasing linear table, when we look at the y column, we're going to be adding the same number each time. If we look at a decreasing linear table, we're going to be subtracting the same number each time. So to describe what's happening in each table, if it's increasing linear, then the y column adds the same number each time. If it's decreasing linear, the y column subtracts the same number each time. Now we'll look at our new relationship, exponential. There are two types. There's exponential growth and decay. When you see exponential growth, you're going to see that you are multiplying by the same number each time. So here we're doing times 2 each time. Exponential decay is going to divide. In this case, we're dividing by 3 each time. So each type of operation has a different title, right? If we're adding the same number each time, it's increasing linear. If we're subtracting the same number each time, it's decreasing linear. If we're multiplying the same number each time, it's exponential growth. If we're dividing the same number each time, it's exponential decay. We'll just summarize that here. So once you've got that written down, we can go to the next slide. In a linear relationship, our tables have a constant rate, or sometimes we call it difference. This means our jumps add or subtract by the same number. In an exponential relationship, our table multiplies, or sorry, that should say increases or decreases by a constant number or percent. This means our jumps multiply or divide by the same number. So let's look at these tables and we'll figure out if they're linear, exponential, or neither. So I'm usually going to check for multiplying first. So if I look at 10 to 50, I would be multiplying by 5. If I look at 50 to 250, that's also times 5. And I'm not sure if it works for 250 to 1250, so I'm going to check. I'm going to see if that works. So I'm typing in 250 times 5, and it does. So that means that this is exponential growth. If we look at number 2, if I go from 0 to 2, I can't multiply 0 by a number and get 2. So I'm going to automatically switch and say this is plus 2. And then 2 to 8 is plus 6. And 8 to 18 is plus 10. That doesn't match either of our patterns because it didn't multiply, didn't add, didn't subtract, didn't divide. So this is going to be a neither. If we look at number 3, to go 15 to 14, there's really no number I can divide by, so I'm going to switch and think if subtraction works. So 15 to 14 is minus 1, 14 to 13 is minus 1, and 13 to 12 is minus 1. So that's going to be decreasing linear. We look at number 4. If I look at multiplying, there's no nice number to multiply 5 by to get 8. So instead, I'm going to check addition. So that would be plus 3. 8 to 11 is plus 3. And 11 to 14 is plus 3. So that means I've got increasing linear. If I look at 10 to 15, this looks like it might be multiplying, but maybe by a weird number. So I'm going to divide to figure out what it's multiplying by. So 15 divided by 10 is 1.5. So let's see if that pattern holds up. So I'm going to say this is times 1.5. Let's see if that works for 15. That gave me 22.5, which is what I wanted. So that means that was still times 1.5. And then let's check for the next one. Yeah, that worked. So if you're ever not sure, remember you can always use the opposite operation to figure out what you're multiplying by. So this was exponential growth. Now if I look at the next one, from 400 to 200, I would divide by 2. And from 200 to 100, that's also divide by 2. And 100 to 50 is also divide by 2. That's going to be exponential decay. So with these problems, there's always be a little bit of needing to kind of look at the problem and decide which is best. It might be a little bit of trial and error, and that's okay if you're not sure right away. Just start trying. See, does addition work? Does subtraction work? Does multiplication work? Does division work? All right, so moving on, we're going to switch gears a little bit. Let's look at the difference between how a linear equation looks and an exponential equation looks. So if we look, the main difference is that an exponential equation has x as an exponent, right? A linear equation has an x with an exponent of 1. So that's an important difference to notice. So in linear, x has an exponent of 1. In exponential, x is the exponent. So if we look at each equation, we're going to decide if it's linear or exponential. If we look at letter A, x is the exponent, so it's exponential. If we look at letter B, there is no exponent on the x, so it's a 1. So that means it's linear. If we look at letter C, x is the exponent, so it's exponential. All right, the last thing we're going to look at is how the graphs look. Increasing linear is a straight line that goes up. Decreasing linear is a straight line that goes down. Exponential growth is a curve that goes up. Exponential decay is a curve that goes down. So when it's linear, we see a line, and that's where the word linear comes from, linear line. Exponential, you're going to have a curve. So we're going to draw a sketch of each equation using our graphing calculator, and then we're going to say which type of graph it is. So I'm going to go to my y equals screen. I'm going to type in 2x minus 3. Okay, so my graph looks like this. And since it's a straight line that's going up, I know that it is increasing linear. Let's try the next one. And I just noticed my 5 did not type. Okay, and if I graph that, it looks like this. So since I have a curve that's going down, this is exponential decay. All right, and if we look at the last one, I've got 4 times 3 to the x. So that looks like this. So that's going to be exponential growth. All right, now next type of problem. It says the estimation of the population of rabbits in a neighborhood over the course of 15 weeks is shown in the table below. Is this relationship increasing linear, decreasing linear, exponential growth, or exponential decay? Explain why you chose this relationship. So first we're going to look at the table. To go from 10 to 30, I know I can multiply 10 by 3. To go from 30 to 90, I know I can multiply 30 times 3. And to go from 90 to 270, I can multiply 90 times 3. So that tells me that my relationship is exponential growth. And the reason that I know this is the population is being multiplied by 3 each time. All right, last problem here. It says, using the pattern in the table, fill in the remaining blank spaces, show the given relationship. So the first work row is already filled in. So we're just going to type that into the calculator. Oops, I messed that up. There we go. I got 30. So now I'm going to fill it in just like the last one. So here the 20 went first. So now the 30 is going to go first. And then the 30 also goes in the parentheses. So 30 plus 0.5 times 30 gives me 45. So now the 45 goes first, and it goes in parentheses. So I get 67.5. And now the 67.5 goes first, and in the parentheses. And I get 101.25. All right, so that is all that I've got for these notes for you today. Remember, if you have any questions, you want to try rewatching the video and then reach out to me if you still need some help. Good luck.